In this DeBacco University video, we'll be going over the trends and explanation of ionic radius of atoms. Keep in mind this is different than the atomic radius, so if you haven't watched that video, you might want to go back and watch that one because we're going to see how things change. So as the atomic radius is the radius of the atom, the ionic radius is the size of an ion, or cation, or anion. And we're going to see the difference between the two. As a reminder, your cation is going to be your positively charged ion, your anion is going to be your negatively charged. And the ionic radius is the distance between the two nuclei. We're looking at the center of that nucleus to the outermost electron of that atom. We could see how things change drastically. Here's the sodium atomic radius, and here's its ionic radius. Forms a cation, it's going to be a much smaller radius. Versus our anion, our chloride, versus when it gains an electron, it's going to change its radius, and here it's going to be larger. So again, as a reminder, cations, those are going to be your positively charged ions. Those ionic radiuses are going to be smaller than their neutral atoms, simply due to the loss of outer electrons, reducing the electron-electron repulsion and allowing the nucleus to pull the remaining electrons closer. We see that evident right here with sodium. Losing that outermost electron, we've lost a shell in this example, and we can see that radius is getting smaller for this cation of sodium. Again, the ionic radius of a positive ion is smaller than the atomic radius for that element. You can see that true here. You can also see the red circles representing the ion, where the gray circles here are representing the atom. We can see in all of these cation examples that radius has gotten smaller. Looking at the anions now, well, they've got the opposite occurring. So the larger than their neutral atoms due to the added electrons, increasing the electron-electron repulsion and expanding the electron cloud. So chlorine is an example here, fluorine is an example here. Again, the exact opposite. The irregular neutral atom represented in gray, and the anion gaining an electron represented here in blue. We can see all of these anion radiuses have gotten larger. Now, what are the trends? Well, if we look across a period, ionic radius generally decreases for cations due to the increasing nuclear charge. And as we go down a group, the ionic radius typically is increasing due to the increasing number of electron shells. And we could see here again the example of the ion versus the regular atoms. And we can see the differences in those trends of those ionic radiuses. Now, when we look at orbital notation of these ions, by forming ions, remember that the atoms become more stable by filling their outer shell to represent a noble gas, per se. And this is why electrons are going through this formation of ions in the first place, to increase the level of stability. But we can also see how that impacts their radius.